Ever sat at a red light, wondering if it would ever change? What if that delay wasn't just bad luck, but someone deliberately holding you there? The systems controlling our commutes are more vulnerable than we think. Those red, yellow, and green lights? They're the city's gatekeepers. If you control them, you control the city's flow. Hacking traffic lights isn't science fiction, it's a real threat. We trust these automated systems, but that trust is often misplaced. Much of our traffic infrastructure is old, patched together from different eras, creating vulnerabilities. Imagine the power. With a few keystrokes, a hacker could gridlock a city or block emergency services. The same tech that brings efficiency can be turned against us. Every new connection, every sensor, every networked light is a new door for attackers. That blinking traffic light, it's not just a switch, it's a computer, and any computer can be hacked. The unseen hand isn't just a metaphor anymore, it's a real, tangible threat. Understanding this risk is the first step to defending against it. Our cities are becoming smart, but with every upgrade, we add new points of failure. The question isn't if, but when and where the next attack will happen. To hack a traffic light, you need to know how it works. Old systems use simple timers, reliable but inflexible. Modern traffic lights are networked computers, making real-time decisions based on sensors, cameras, and radar. Each intersection has a controller cabinet, the brain of the intersection. These controllers talk to each other and to a central management center, creating a coordinated system. The goal: smooth traffic flow, green waves, fewer stops. Communication happens over fiber, phone lines, or increasingly, wireless networks. Wireless makes upgrades easier, but also opens new attack vectors. Today's traffic lights are part of a vast, interconnected system. Think of it as a body. The management center is the brain, the network is the nervous system, and the lights are the hands. This complexity keeps cities moving, but it's also a weakness. A single failure can ripple across the whole system. The more connected we get, the more vulnerable we become. Traffic lights are no longer isolated, they're nodes on a hackable network. One breach can have citywide consequences. Many cities run on decades-old technology. Traffic controllers aren't replaced often. They're built to last, but not to withstand digital threats. Most were designed before cybersecurity was a concern. The main worry used to be weather or vandalism, not hackers. Old hardware and software often lack basic security. No encryption, weak or default passwords. Manuals and default passwords are easy to find online. Physical security is weak too. One master key can open every cabinet in a city. Keys can be bought or copied, and once inside, a hacker can reprogram lights or install malware. Attackers don't need to be geniuses, just persistent. The information is out there, and the flaws are well known. Upgrading an entire city's infrastructure is expensive and slow. So, outdated systems remain, full of holes. The perfect storm: old hardware, insecure software, and weak physical controls. Even a curious teenager could exploit these weaknesses. The real problem isn't ignorance, it's inertia and cost. Until cities invest in upgrades, these vulnerabilities will persist. Wireless tech is a double-edged sword for traffic systems. It's cheaper and more flexible than running cables, but it broadcasts control signals into the open air. Many systems lack strong encryption. Data is sent in the clear. Hackers can use cheap radios to eavesdrop and reverse engineer commands. Once they understand the protocol, they can send fake commands, turning all lights green or red. Even when encryption exists, it's often weak or uses shared keys. If one device is compromised, the whole network is at risk. Manufacturers reuse keys for convenience, creating a single point of failure. Wireless convenience has opened the door to widespread disruption. The city's nervous system is now exposed to anyone with the right tools. One breach can paralyze entire neighborhoods. The most dangerous attacks target the city's broader network, not just the lights. A city's IT infrastructure connects everything: police, libraries, and traffic management. Hackers look for weak links, like a phishing email to a city employee. Once inside, malware gives them a foothold to move laterally through the network. The ultimate target, the traffic management center, the city's traffic brain. With access, a hacker can view cameras, change signs, and control every light. They can launch coordinated citywide attacks with a few clicks. These attacks are stealthy and scalable. Hackers can lurk for weeks, learning the system. Subtle disruptions can test their control before a major strike. When ready, they can gridlock downtown, block emergency routes, or create chaos as a distraction. The Trojan horse approach gives attackers the keys to the kingdom. One breach can cripple an entire city. The threat is real and growing. What happens if every direction gets a green light at once? The result, chaos and devastating collisions. Hackers could trigger all green scenarios, causing high-speed crashes and serious injuries. Or they could turn all lights red, freezing traffic citywide. More subtly, they could tweak timings to create gridlock. Short greens on main roads, long greens on side streets. Emergency services would be trapped, unable to respond. The economic impact, huge. Lost productivity, wasted fuel, delayed deliveries. The city's reputation would take a hit. Who wants to live or work where infrastructure is so vulnerable? Beyond the physical damage, there's psychological fallout. Trust in traffic lights would erode. Drivers might ignore signals, making roads even more dangerous. The hack undermines the social contract that keeps cities moving. Fear and uncertainty replace order. The damage isn't just to property, it's to the fabric of urban life. One attack can shake public confidence for years. The consequences go far beyond a single intersection. It's a threat to the city's very sense of safety. These aren't just hypotheticals. Traffic light hacks have happened. In 2014, researchers in a U.S. city accessed the entire traffic network using default passwords and unencrypted radio. They could change lights, cause gridlock, and shut down intersections, proving how easy it was. In 2006, two Los Angeles engineers, angry over a labor dispute, hacked the city's system and jammed traffic for days. They were caught, but the damage was done. In 2008, a Portland teenager accessed controllers just by pressing buttons, no computer needed. He changed lights for fun until he was caught bragging. These incidents show the threat isn't just from sophisticated outsiders. Insiders and even pranksters can exploit weak security. The tools aren't exotic, just default passwords, unencrypted data, and poor physical security. Each incident is a warning. The vulnerabilities are real and exploitable. So far we've been lucky, no catastrophic attacks. But luck isn't a security strategy. The next incident could be far worse. The time to act is now. Securing traffic infrastructure requires layered defenses. No single fix will do. Start with basics. Change default passwords. Enforce strict access controls. Encrypt all data between controllers and management centers, especially on wireless networks. Use strong, up-to-date encryption and avoid shared keys. Segment the network. Traffic systems should be isolated from other city departments. Firewalls and network segmentation make lateral movement harder for attackers. Monitor for unusual activity. If a controller acts strangely, alert a human operator. Have an incident response plan. How to regain control, switch to fail-safe, and repair damage. Security isn't just about prevention, it's about being ready to respond. Treat traffic networks with the same seriousness as banking systems. Every layer of defense matters. The goal, resilience, not just protection. Our streets depend on it. Traffic lights are the unsung heroes of city life, but their technology is fragile. The threat of a malicious takeover is real and growing. Cybersecurity must be a top priority for city leaders, not just IT staff. Funding is needed to upgrade legacy systems and implement modern security. It's not glamorous, but it's critical for public safety. Citizens should demand action, ask officials about traffic light security and incident response plans. Public pressure can drive real change before disaster strikes. Cities must see themselves as digital ecosystems, not just roads and buildings. Every new smart device is a potential vulnerability. Security must be built in from the start, not added later. By investing in resilience, we can keep our cities safe and moving. The future of urban life depends on it. Let's make sure our smart cities are secure cities.